Hello students, today we are going to talk about the access methods which are available in our file systems. So if you remember in the previous class we were talking about the file system introduction, right? So when we say introduction, I hope you remember the things what we are dealing with, like what files are, what are the operations you can perform on the files, and we were also discussing what are the attributes of a file, right? So once we are done with all those, now we will be talking about access methods, a very important topic as far as your exam point is concerned, right? So when we say access methods, what do we mean by it is, generally we know file is basically a unit of storage, right? Means file stores information. So whatever information is stored in a file, we need to, whenever we require, we need to access it. We need to access it, access the information that is there in your file. So to access the information within a file, we have different ways of accessing the information. These different ways of accessing the information are actually called as your access methods. What are they? Ways of accessing information within a file. That's what is your access methods, right? Now, the common access methods that are available are, basically we have something called as sequential, and we have something called as your direct access method. Sequential access method and your direct access method, right? Now, other than the two, we will also be just focusing a little bit on some other access method called as your index access method. We'll just talk about it in short, like what it is and all, right? So first let's start with our first one, sequential access method. As the word itself is being spelled sequential, right? Like simple, it's basically a simple method that is available for accessing records in your file. And as we say it is sequential, I hope you know the meaning of sequential, right? It's like one after the other in an order. It always accesses the data in an order, like one after the other. At the same time, your the implementation of, means where you use this sequential access method, if we say, we have something called as editors and compilers basically prefer this way of accessing your data. It's nothing but your sequential access, right? Now, coming to the operations that are supported in a sequential, we have two operations, very simple. One is your read operation termed as read next. The other one is your write operation termed as write next. When we say read operation read next, basically read reads the next record. We can actually call them as records or blocks, okay? It reads the next record or blocks and automatically increments the pointer. Right? And similarly, when we come to a write operation, write basically writes data or record, you can say, as you say, or you can say a block to the end. To the end it will be writing the data, and automatically, as usual, your pointer is incremented, right? You might be thinking why we actually are going on telling incremented and all, because we know in files we always have something called as a file pointer, which always points to the current location or current record on a file wherever you are accessing or reading. For that reason we are using this word called as file pointer, right? So I think with these two operations of read and write, we also have one more operation actually called as your reset operation. Means whenever you want to bring your pointer to the beginning of the file, you can just use a operation called as what? Reset, right? So finally, sequential access, you can just formulate it in this way, ma. If this is your current location, you can read or write in a order one after the other as it goes on. If you want to come to the beginning, you can just go for a rewind. This is your rewind and this is your either read or write operation. And finally, the operations, hope you remember: read, write and reset. So this is all about your sequential access method. The advantage is its simplicity. The disadvantage is it takes long time to access records which are at the end. Like for example, as I have told you, sequential, if you want to refer 39th record or block, you need to go through all the 38 blocks. So this is what is a disadvantage with your sequential access, but it's very simple. Now we'll move on to the next access method that is available. We actually call it as your, it's your direct, we can call it as direct access method. It's your direct access method. Now, so when we talk about the direct access method, this method, for a few reasons, because it's direct and you can access wherever you want, we actually also term it as something called as relative method. We also term it as what? It's your relative method. In this direct access, there are actually no restrictions in the order of accessing records. In the order of accessing your records, there are no restrictions. You can access wherever you want, right? And in this method, we go with an assumption that all the records of a file are of fixed length. This is actually the assumption, or we actually consider this as it. And one more assumption or one more property is your direct access can generally be applied only on disk models. Hope you know what do you mean by disk models. Means whenever you are you store your data on disks, to retrieve such data stored on disk only, we can make use of your direct methods. That's what you mean by disk models. And defaultly we know our secondary storage always maintains a disk. So default actually it's a disk model where we are using your direct method. And where do we actually have the usage of direct access method is, we have a benefit or we have an advantage whenever you want to access large amounts of data. Like defaultly like databases, you can take it as for immediate and faster access. You can go for direct access method, right? Now, so when we consider the operations as in your sequential access methods, operations are similar. You have your read and write. There we were having something called as read next and write next, but here we have read n and write n, because directly you can access whichever record you want. Like for example, I want to read 39th. If it is your sequential, you have to complete all the 38 and then come to your 39 to refer to this one, because one after the other. But when you go for your direct access method, whenever you want to read 39th record, you simply say read 39. That's it. You can directly access it. So it's your read n and write-in and not your, it's not your read next or write next, right? Now, in this type of access method, basically your blocks or records, whatever I am saying, blocks or record, the numbers of blocks or records, means record numbers or block numbers, are generally provided by the user to the operating system. Means the blocks or record numbers are all your logical view, what is actually provided by your user itself, right? Now talking about the support to such type of access methods. Direct access method is generally supported by different operating systems, many operating systems, and you actually have few operating systems which supports both sequential and your direct access method. But there are few which will support either only direct or only sequential. So just summarizing the operations what we have, let's just go through the operations when we have a small comparison study like, right? So as you have reset here in your sequential, we will be having the pointer is set to 0, means n, 0, the starting location. Here reset is your beginning. Here you have something called as read next. Here you have something called as read in. Here you have write next. Similarly, you have your write in. That's it, right? And whenever you read or write, always remember you have something like your n or whatever, CP whatever, your n is equal to n plus 1, and here also your n is equal to n plus 1. You automatically increment after your implementation. That's what we were saying, right? So this is all about your direct access method what we have discussed. And we also have, I think we were talking about, there is also one more thing called as your, we have something called as your indexed access method. Like actually this indexed access method is considered as other access methods. We will actually talk about that one. Your index is considered as your other access method, means this is not mentioned, but this is one of the one which having an advantage, right? Now, so this is your indexed or index access method. Now, this access method is basically built over direct access. It's built over direct access method, meaning that it takes some of the properties of direct access method and then it works in a similar way. In this index access method, how this access method works is, you maintain an index, you will be having an index as you have your index for a book, right? So whenever you want to turn to a particular page, for example, you want to go to 39th page, what do? You check actually 39th page or the topic, whatever name you go for, you first check your index, see where it is, the location, and I will directly move to that location. Yes or no? That's what we do. So here also, as you maintain an index, whenever your operating system refers to a particular record, some 39th record or whatever, you first check in your index where it is for the location and immediately move to that location. Like if your location is considered as your n, 39th, n is your 39 if you consider, you will actually go for that and you will have to read your n. So here, don't you think once you give the location, you're directly accessing that one? So here it is actually performing something like direct access method only, no? But what we are doing initially, what we are adding extra is, you are maintaining an index. Whatever is asked by the OS, you are first checking the index for the location and then you are directly moving to that location for reading that amount of information. So this is what is your index access method, The advantage what your index access method gives you is, instead of, whenever you want to move to a particular location directly, if you have an index, you will be able to access that particular piece of information at a faster rate. Just imagine your book does not have an index and you're searching for a topic. So will that be comfortable, or will you be more comfortable when you have an index and you are given a topic and you can directly move to that particular topic? So undoubtedly, whichever is maintaining an index, it will allow you to have a faster access. So your index access method is always preferred over other access methods. And sometimes what happens is index sometimes reflects some disadvantages. Like for example, when you have more entries, in your index table, so that may not fit in your memory. Means the table may become very big. Index itself is of 10 pages if you remember. It becomes very big to place it in your memory. In that cases, you can actually break down your index into primary index and secondary index. Primary index and your secondary index. Means you will maintain a primary index, like for example maintaining you will say 1 to 10 records, 11 to 20 records. This is your primary, and secondary will contain what? This 1 to 10. So each one, this is your primary index, this is your secondary index containing your actual data. If you break it like this, what happens is when you're searching for 39, for example, what you can actually do is, instead of searching all the indexes, I can directly go to a position where I have between 39, means 31 to 31. Directly I will search this one for 10 entries. I'll understand it is here. From here again I'll go to your block where it contains the 31 to 40. So don't you think referencing 39 is becoming more faster when you compare to the other methods? So this is basically the advantage with your index method. And this index method is basically preferred by many different famous operating system companies like IBM, which basically prefers your ISAM. I hope you heard this word, ISAM, Indexed Sequential Access Method, is basically preferred by your IBM. And this is what is indexing. You can also add one more table which shows like this, index table, where see this is your index file and this is your relative file, or file which is actually containing your data. So, and if you to go for this one, primary index and your secondary index is actually containing your records, right? So this is all about your what do you say, it's all about your direct access method, and you have your sequential access method. So this is all about your access methods. Thank you.